Hello everyone, welcome to lecture number 10 of uh, IoT. So last time we discussed about how to get a start with Arduino, how to plug it into the PC, from that to run your first test code and to see if all the checks and balances are there, right? So that means if to see if the code is uploading correctly, right, and to do the necessary steps for starting a process. So you know now by now, okay, how to what is needed to be installed, right, the IDE, and what is how to upload a code and a basic understanding of the code itself, right? Then we are in this lecture we are going to take some baby steps to understand the coding. We are going to take some baby steps to understand the coding. So what we are going to do now is, in the last lecture we used the LED that is there in the Arduino itself to blink, right? What we did was we used the Arduino was own LED bulb to blink. We are going to now bring it a step further and use the same code to blink, to activate or to make a external LED bulb blink, right? What are we practicing from this is that, right, uh, I think in this semester there are no practicals that is being run. So so this will be purely theoretical explanation, right? I will do my best for uh, for giving you an idea how this prototyping and projects work. So we will start from the first few steps, right? We will start from the first few steps and we will move forward from there, right? The most simplest one is the LED, right? Then when you have the feeling, when you have the idea of what we are doing, then we can go into the next step. Of course, the picture you can see over here is the simplest practical in Arduino Uno which is taking place. You can see the wires are being connected to the breadboard itself, right? Then we have the LED bulb, we have a resistor over here, we have this is yes, slot number 13 giving power. Then we have the ground, right, as well. So on and so forth. So how to do this, what is going on? So you will see three wires over here, but if you see the next diagram you will see that this can be done by two wires. Here what is happening is that they are using, right, the if you see the connection of the signal which comes through this wire, and it is right, and when using a breadboard these are interconnected. Therefore that when that signal is given to this line, the entire line has the signal. So that is what's happening in across here. So this wire is transferring that to the LED bulb itself. It's not a clear picture. I just wanted to show you how it would practically look like when you make it, right? Two wires is more than enough to make it. A practical diagram of using a LED bulb would be like this, right? So you will have your Arduino Uno, right? Your Arduino Uno will be connected to your PC, as you can see from here, right? When we talk about the Arduino Uno, we talked about the power supply unit, right? In this case, when coming into very small devices which use less power, you know that we can take 5 volts from our USB, right, connection, and that is more than enough to run this, right? As you can see, the connections are being established in such a way. Before going into the code itself, let's look at a small demonstration of how these LED bulbs um, are fixed, why are we selecting a resistor, what is a breadboard, so on and so forth, right? Just to get yourself familiar with the situation. Okay, so I have this small video. I will share this video on the uh, course content itself, right? This gives you an idea on how to build this project. Again, as I told you, we are going to take very small baby steps, right? Before going into advanced, before knowing advanced scenarios, so before making advanced IoT um, devices, projects, or advanced IoT or any advanced code, right? We have to start from the very basic. We have to understand the very basics, right? After you learn these very basics here, you don't need to repeat it anywhere, right? Then the next thing you will be doing as a project, or the next thing you will be researching as a project, the next thing you will be um, looking into IoT, or looking for prototyping of IoT and so on and so forth. It can't be this, right? The idea of teaching this now is that showing you the path of by taking small baby steps, showing you how this is being done, right? After that, the next steps are easier because you will be able to find the code. You will be able to you will know where to find the code. You will be able to understand the code. You will be able to do the connections, read the diagrams, so on and so forth. After that step, it would be making your own diagrams and connecting things and so on and so forth. So those are step by step you can move forward. These are the very first steps that you will be taking, right? So here we have a LED bulb. So our main need here is to make it blink, right? Okay, so those are the content you need, right? When you want to access a project, if you are in a lab, or if you find yourself to have a Arduino, and if you are going to do this project by yourself, what will you have? You will have a Arduino, couple of wires, right? You will have a LED bulb and a resistor. Now your curiosity should be mainly towards the resistor itself. Why the resistor is there? Because we know that there's already a LED bulb here, and we light it up. There were no resistance or anything involved. So let's see. Okay, this is what is known as a breadboard. Uh, Basically, why do we use breadboards? In breadboards, it is easier to make connections without needing to bout things in, right? Without needing to using any hot guns or anything. We don't need to uh, uh, solder anything in, right? So soldering means that we have to it's a very light version of, think of it as a very light version of welding, right? And we use it to make connections in circuits. But when you are practicing, when you are when you're practicing with wires, right? When you are practicing and prototyping, you would sometimes need to connect it in different ways to see if it is working. Maybe you have to change your circuit, maybe you have to add a new part. So rather than permanently fixing, it is better to have a a breadboard where you can use it like Lego, right? Like you have those Lego toys where you connect each other and you can break it apart. And if you want to build something else, you can use the same Lego blocks to connect it together. Think of this, think of Arduino, think of the Arduino sensors, LEDs, these wires with the breadboard itself. Think of it as Lego pieces. You are building advanced Lego pieces. So we will not be permanently fixing them together using a breadboard. What we will be doing is we will be using, here you can see that there are all these connectivities are female connectivities, so there will be male connectivities. You have to choose the wires with male connectivities, right? In the Arduino board itself you will have female connectivities, so you will again have a male connectivity. So both ends of the wire would be a male connectivity, right? So now you can see that this LED will be fixed to this breadboard, and so you can see these middle columns over here. So now what you need to know is practically along this line, right, and along this line are internally connected, right? They are internally connected. So therefore, right, if you plug this LED bulb over here, anything which is connected in this row, right, will have a connection to this LED bulb. If we use any hole over here, it would have a connection to this LED bulb, right? Similarly, same thing, if you have a let's say a wire from here, that if you need to pass that information for something over here, it will transfer it internally because these are interconnected, right? So what is being shown here is that these two pieces or the leads, right, should be in different columns because these are interconnected, right? So if you take a breadboard, you cannot have it in this way. You have to fix it horizontally, not vertically. So here we are going to talk about why we are going to use a resistor. So there's going to be some mathematical models coming into play, right? I will not include that for the subject matter currently, right? But for your understanding why we are using a resistor, for for that we will just, because this is more towards electronics, but we will try to get an understanding why we are using a resistor. Okay, so here it's a red LED, we have 2 volts, then we have 3 volts for a blue LED. So this is the equation that we goes for to understanding the resistance which is needed, because normally the outcome of this from Arduino is 5 volts. I think that is important to remember every time when you fix any sensor or a LED, right? In electronics, right? Uh, the lesser the voltage would be better. Because it's on the safe side, right? So here we have, okay, 200 ohms. Let's say we used a 250 ohm resistor. The brightness of the LED bulb will be affected because of the 200, so we have 50 ohms more. But it is better than having a 100 ohm resistor, because the voltage will be too much, it will burn, the LED it would burn. So uh, so less LED light is better in respect to uh, in respect to burning your circuit. So always remember, it is safe to, when coming into resistors, when coming into the voltage which is being used, right? If you have something which is 10 volts, right, and if you are trying to connect it to a 8-volt power outlet, right, as example, it would not function it's properly, but it will not burn. If you have, right, and similar, we are talking about electricity amperes, it's the same case, because as you can see from the equations, right, this is V equals IR equation turned into other way around. I hope you have a basic understanding of V equals IR. If not, there's no problem. For this course at the moment, we are not much focusing on these equations, but I think in A levels you should have gone through this in physics, right? So it is better to always have it a less, right? But this equation would roughly give you around 200 ohms is a good value to use for LED, red LED bulbs. Okay, so for the blue one, they are also calculating it for the blue one as well. So they are using a 220 ohm resistor. They are going a little bit higher. So that means they are going to be on the safe side. This is good in prototyping ethics or electronic ethics, right? Because you will not burn your circuit. So now you can, if you can understand how the connection is being done. So it is connected in a series fashion. If I remember correctly, these things should be there on these parallel connections and series connections. These things should be there on your A level physics as well. So I think you have a somewhat uh, somewhat of a good idea on when coming into these things, right? As you can see here, right, no parallel connections. We know that these lines, right, these vertical lines are connected to each other. So if this and this are on the same line, that means now here in this line is also having the same, if electricity to flow through, a connection can be made through this line for this line as well, right? um, Again, you can see the video. I will upload the video to the content as well, so you can go through it, you can understand what is going on. So okay, now we have a connection made, right? From Arduino, you can see what are the ports which are being used right here. They have used the ground, and they have used port number 8 for this connection. As you know, if this wire is connected to this line, anything, that means this wire is connected to anything which is also fixed for this line, so that means the resistor. So that means the signal will go through here, through the resistor, into the LED bulb, right? The bulb will light up, then the electricity flow will come back into the breadboard, through the breadboard, from this wire to the ground. So this is negative and positive polarity of a LED. The longer one is the positive, shorter one is the negative. So here the first piece of code is being written. Now you know where it is being written. Now you know how to connect your PC to your Arduino. You know how to upload your code as well. So here the simple code is being written, what we learned for before about the LED bulb, but here we are going to define the pin. So a definition is given that the LED pin, right, there as the value 8, which means port number 8. Right. Next part of the code, it will mimic what we have already learned. Right. Okay. So through this code, right, what you are seeing here is the first one defines that pin number 8. Here the definition is given, so the name of the pin is a output pin, right? These are input output pins. We talked about this before in lectures, right, to understand what is what. So here it is defined as a output, right? Then they are right. So of course this is going to be a digital signature. If the digital signature, we know it is 5 volts, means it is high, means 5 volts, low means no volts at all, right? So here the LED pin, that is the name that we define here for port number 8. LED pin, right? Anybody who practices C++ or C or any basic coding would have a idea of what is being typed here, right? So learning the coding which is needed for this is necessary, and also have to understand it is easy, right? After some time you will get it. Basically what is happening here is defining this name as port 8. Here we are saying that in the body of the code itself, right, pin 8, or the name of that pin 8 is LED pin, is a output pin. Its function is output. We are creating a, then after defining what kind of a pin it is it an input pin or output pin, we are creating a loop, right? It's a loop, as in it could be while do while loop, right? Here we can define it as a loop. So this digital, so here we are writing that LED pin, which means port number 8 here, right, is high. High means, again, that means 5 volts. We are switching it on. Delay for 1000 means, we learned about this, right? It will stay on, it will stay on for 1000 units of the particular time period we are given, right, before going into the next step. So it will be, as the code reads, right, it will go here. Now it is high, that means the bulb is switched on. It will stay on high, so there's a delay happening, so it will stay here for until 1000 has reached, right, 1000, let's say, for our benefit here, let's say 1000 milliseconds, right, until 1000 milliseconds have reached to go to the next step. Next step, it becomes low, that means it is low, means it is 0, that means it will switch off, and again it will be delayed. So this will happen in a loop: switch on, switch off, switch on, switch off, switch on, switch off. By defining the delay period, we can actually change the speed of the blinking of the light itself, right? So we are uploading. Okay, now you can see, now it's blinking, right? You can see they are changing the speed of the blinking light on the go, right? You can see how those differences have been taking place. This channel has this YouTube channel also have other circuitries, but this is the main one I wanted to show, right? So because this is the first step that we are going to take. Again, we connected our bulb, right? In this circuit, the port is different, right? Don't let simple things like, okay, the port is different, uh, or the connectivity, this is different from the one that we on the video. uh, don't think like that. Try to understand what you're seeing. It doesn't matter. Okay, the ground is always the ground. You can connect it here, you can connect, there's another ground over here, you can connect it here, the function will be the same. You can connect it here, it's on 13, you can connect it on input output 10, 5, it doesn't matter. So where, if we connect it on 5, where should the code change? We have the code here. Here it is, this code is written according to this diagram, right? We talked about it. Pin 13, right? If we are to say, okay, pin 13, that means the signal will go through pin 13. If we connect this to pin number, let's say 5, input output pin number 5, what is needed to be done, right? This number should be turned into pin number 5. That's it. So this is also another way of defining the pin number. You can see in the video they define the pin number in a different way, right? This is also another way of, the same thing happens, they have defined a pin over here. Basically what is happening is we are giving a name to a certain pin number, right? And we are using that name to define the activities that will happen on the pin number. So first thing to do in a code, right, in a Arduino code, right, after you when you after you done the circuitry, or when you have done the connectivity, right, then you start the code. So you have to keep in mind what are the pins that you have connected to which one. This one, as I told you before, as we are taking baby steps here, it is quite simple because it's only two wires. But think of, okay, you have a LED, you have a temperature sensor, you have a screen, you have let's say a servo motor, all in one circuit. That would be your project, right? So in that particular case, right, you can approach it in different methods. For example, you can start with the LED bulb, see if it is working, okay, then you plug in the next hardware component in. Then you can't use the same port because it's already in use, right? So you have to draw the circuitry, you have to understand the circuitry, then you have to again define, let's say let's say a servo mode is there, so we have to define that pin. Let's say servo pin would be equal to pin number, it would be equal to pin number, let's say 5. So we draw it through 5 and we will connect it to, then we will start our definition of that particular pin. Will it be input or output? For a servo motor, it would be a output, similar to a LED because they are actuators, right? If it is a sensor, it would be input. So we output, then again we define that pin as high, right, 1000. Again we define in so we create a loop, we let the loop run. Okay, if the LED bulb is not to blink at all, so then no need of a loop, we just put pin is on high, just switch it on, it will work as a switch, right? Now if you have a blinking light, right, and if you have a sensor fixed in which would read some kind of a value, let's think of a sensor of the first thing that comes to mind is the next sensor we are talking about. We are going to talk about the temperature sensor. Let's say a temperature sensor is there, we read the value, then we have to define, okay, if the temperature is above this much, we have to turn on the light. If that would be the case, we have to put a if function over here. First we have to take in the values of the temperature sensor, and then we have to put if function, and if the values satisfy, then the void loop will run, then you have a light bulb, right? If it is not satisfied, then it will not. But the whole thing should also run on a void loop itself, because the temperature should be monitored all the time. Now you will understand, if you can grasp that particular concept, that means we have created a thermostat. It is simple as that, right? So here I have given step by step small explanation on what is what. So we have gone through it, right? We start by defining a constant variable. All right, this is the constant variable, we talked about it, and assigned it to the value 13. Value 13 means pin number 13 in the in the Arduino Uno IED, right? Remember, we select, right, when starting, right, we select what kind of Arduino board we are going to use. So we have to remember that we have to do those things first before starting the project. Why? Because in another Arduino, this is Arduino Uno, we can select 13 as a input output. But if it is not if it is not Arduino Uno, if it is a different board, pin number 13 could be different, right? So you have to see what kind of a board you are using, what kind of, so these things are small things that you should remember when doing your project, right? Because these are the starting steps. You have to, like, these are foundational baby steps and things that you have to keep in mind, right? So defining the value, we talked about how we can define any input output value, right? Because we are using the Arduino IDE, right? When we say okay, well, when we give value 13 and we have selected our Arduino Uno board, it will automatically configure port the port 13 in to give out the signal, right? If you change that 13 value over here to, let's say, 10, then the output will come from 10. If this value is, let's say, 5, or let's say it's 2, will this circuit work? No, it will not work. Why? The connection is at 13. The signal is given out at 2 or 1. We said okay, 1. So or if you say okay, if it is 6, we define it as 6, the value here at 6, and if the same circuit comes, still it will not work. So we have to change this wire, we have to remove it from here and plug it into slot 6, then only it will work, right? So when designing those things also remember, because when you are self learning these things, if you are interested in these things and if you are self learning these things, if you are going to go into projects and to self learn, right, these small things are the important things. You should be able to look at an example diagram and build your own thing, but the example diagram would be different from one example to another, but you should be able to get the idea. So in setup function, we configure pin as a output 1. Yes, we have done that. We configure here, we set up it as a output pin, we give a definition to it. This tells Arduino that we want to control the LED and set it as a output pin. Basically, yes, what is done here is we are saying pin number 13 is a output pin. It is going to give a output. The loop function is where the main action happens. It runs rapidly after the setup function has executed. Yes. Inside the loop function, we first turn the LED bulb LED on by setting LED pin to high using the uh, digital write function, right? These functions are common functions which are there, right? So by learning or by taking Arduino code book, right? These set up functions, right? You will have a idea about them, and um, you will have the understanding of them. For now, as we are just keeping our steps as it is, we are not going to fiddle much with the code itself. We are going to keep the structure of the code itself and try to understand what does the code mean. So in a digital write here means that we are saying, we are giving, we are writing a value to that define port 13, which is defined as LED pin. This is the name we have given to 13, port 13, right? We then introduce, yes, 1000 millisecond or 1 second using uh, the delay function, right? Then after 1 second we write it again, repeat it, but this time we digital write as low. That means um, we know this how a digital signal goes, right? A digital signal, right, is binary 1 0 1 1 0. This is how it goes, right? So a digital signal, you have x and y axes, right? This would be 0 point. So when you have 1, you will have 5 volts. So 5 volts will be the output. So here the according to this code, what would be the output of this, right? So the output of this would be pretty much simple. It's going to be 1, wait for a second, 0, then 1 0 1 0 1 0. It will just continue, right? Keeping a gap. The signal would be like this. So that would be 5 volts. Then this is the timeline. This is time t. So for 1 second it would be 5. Then for another second, so it's one second it would be 5. For another second it would be 0. No volts. No volts. No volts going through that port or line to the LED bulb means there will be no light, right? Then after 1 second again 5. 1 second going down. So it will be just going like this. With 1 second, it's just changing the volts. So that's how the light blinks and turns on and turns off, turns on and turns off, right? So whatever the system you will be using, whatever the program language you will be using, whatever the if it is Arduino, if it is Raspberry Pi or any other circuitry board, end of the day what will be happening is that a signal will be given and a signal will be taken out, right? It switching on and off, switching on and off. The fundamental of it is going to be that the loop function then repeat from the beginning, causing the LED to blink on and off at a second interval indefinitely. Yes, so it's a loop function. It will keep on looping itself. Right? So I think you understand what is going on. Now we can go for the next example. right? I hope you understand. This would be much better if there is a if there's a practical approach for this, but unfortunately for this lesson we can only do theoretical approach. So I'm trying to I will upload some videos which will give you some visual aid in how this process takes place, so you will have an idea of how to fix things in the circuitry, how to use a breadboard, how to use the wires, and how to use the Arduino itself. And I will try to also introduce at the end of the lesson I will try to introduce virtual circuit making platforms, online platforms that you can fiddle around, you can check it around to learn the code, to understand to learn the code, to learn about what sensors, how it functions, and so on and so forth. Okay. So for the next part, in this part, what we are doing is we are just same example. We are going through the same example. We are just going to change. We are talking about the examples we were talking about earlier. We are just going to change our LED pin to 9, and we are going to test it out. So this was the example that was given there. Mainly we talked about these things, right? On the video itself, when it is connected to pin number 9. So here of course it is the normal LED blinking code, right? And we went through the code. Yes. Port 13, we know that port 13 is already connected to there is a LED on port 13, right? We know this, right? This is the LED over here. We know this, that this LED is there on port 13. But now if we are to connect an external one, let's say for port 9, right? Same code, right? You will end up only the connection should be changed, right? We have to take it to digital, so the long leg of the LED, right, the positive side goes to pin number 9, connect the negative or the short end of the LED to the resistor. And we now talked about why we need a resistor, what kind of resistor we need, what are the equations that we use for the resistor itself, and we talked about why we and the main point is why we need a resistor, right? If you remember a couple of lectures before, we talked about when selecting our sensor or actuator, we talked about what exactly the properties of that particular device we are buying, right? We talked about the data sheet, we talked about the primary information. In that you will see the amount of voltage that it takes in. So we have to maintain it around that level or a little bit below that, not above that. Anything above that would damage. So this use of the resistor is for that. So then ground in the pin. I think we have gone through this more than enough and you have a basic understanding of it. Yes, of course the video, this will be there as well. Now if this is one traffic light, what will happen now? What would be a simple example of IoT device? Or what will happen if we want to add another bulb in? So this is a example picture of what a traffic light would look like. Isn't it? If we can control the frequency of each of these bulbs, right? We talked about it here in the code, right? Here it has 1 second, right? We talked about it. So if we can delay each one, and first the red, then in the amber, then the green, right? If we can make them in a frequency, aren't we able to make a traffic light? Yes, we are able to make a traffic light. So this is a simple example of a traffic light functioning, right? I will take a little bit more time to talk about the breadboard itself, right? You can see that here these positive and negative lines are connected, and you see these two lines, which means what each connection which is made to, so these two lines which I'm drawing here will share, if one of them is connected to the current, the all these lines together will be connected to the current, this line as well. They will stop from here, they will come up to here and stop. So you can see in this breadboard what this person has done is they have connected these two with these two. You can see the wire over here which is pin, which makes all these lines connect. So all these lines are connected, so same thing has been repeated on this side as well. You can see the resistors, right? And you can see the black color ground cable. This guy has done it in this person has done it in style. You can see that he has used black color for ground and done it very perfectly and smoothly, right? Very organized fashion. You can see that all these resistors are connected to the ground. Here you can see ground, here see ground, and all those are, this whole entire line is ground, running the ground. That means 0, right? It is communicating with this arc to here, so that is running the ground level. Then you can see that each of these 3, 4 and 5 is used to connect to here, from here, here to here, here to here. We know that these lines are not connected this way. No, they are not connected that way. They are connected this way, parallel, right, up to here, up to this point. So if you put a plug over here, we can connect another device to the same current through here. If we have one over here, if we have another one, same thing, same scenario. So I hope that that part of the breadboard is also been covered and understood, right? Now this is a good practical, this is a very simple practical, this is a good way of understanding the LEDs. If you have done, if when the time comes, or if you have the ability to do the practicals, you can first do the LED light, you can do the blinking, right? You can change the values so that the blinking will change, right? Then after that you can function on this matter as well, right? So here you can see clearly that a traffic light is being created. When talking about IoT, we talked about smart cities, we talked about how smart traffic lights are there. So in smart traffic lights, we talked about how cameras can do image processing and get to know how much traffic is there, then change the traffic light. So in that whole IoT system, end device is the traffic light itself. So we are just creating the traffic light. Of course, a real world application of the traffic light will not look like this, we know that, right? Of course, this is a prototype. A traffic light would have more LED lights, it would have more power, it would have and it would be a robust device. There will be a cover built, there will be an entire cover built, and circles will be there to separately. There will be a small flap to cover it from rain, so on and so forth. There will be a pole over here, things like that, right? So yes, of course, that is true, but now we are talking about the simplest form of prototyping, right? So this is a good way of keeping your next step. What is the code necessary to do this? Now you can see the connections are done properly. So what is the code to do this? That will be the next question. When the connections are done properly, when the connections are being carried out properly, right, the next step would be the code itself. Welcome to a small simulation that we are going to carry out, right? This is UoK portal. This is you can access this online, right? Let me open this for you. Yes, you will have this to simulate IoT projects in your browser. This is a good way to learn if you don't need or if you don't have access to IoT devices. We can select our Arduino, and then we can say, okay, we are now working with Arduino Uno. If we are working with Arduino Uno, okay, so what was the code that we are running? So here you can press the plus button, you can select your set of actuators or sensors, depending on what is it. And you can also get breadboards, right? Additional these things are logic gates. Those are mostly for electronic students, but if you are to take a path towards IoT, those things are also important. But our first example is the LED light, right? We talked about LED light. So there are different color LED lights. We can change the color of our LED light to any way we like, right? So then we have the Arduino Uno board, which is very familiar with us. We talked about something else as well. What else do we need to complete this circuit? We need a resistor. When you got the resistor, okay, 1 kilo ohm. Is 1 kilo ohm okay? Yes, it should be okay, because according to the equations we had, it was around 200 ohms, if I remember correctly from the equations. Yes, so we are going to connect this to this, and this will be connect to, let's say, port number 2. Port number 2. And where would this go? To the ground. Okay, we have the set, and we have ground over here. Okay, now we have to jump to the codes. I am just going to not to take much of your time. I'm just going to copy this, and I'm going to paste it over here. Right, okay, these two are irrelevant for now. We are just having one code. Okay, we have named this red LED. Yes, it's output one. It's hide, void. Okay, so we have all completed this, and technically this should run. So as you can see, now we have defined it to the second one. We have already added this to the second one as well. So when we run this, let's see, it's running. Yes, okay, now it's running. Processes are ongoing. You can see that the LED bulb is now flickering. Okay, now we can stop running for a moment. I think we should change this value and see. I'm going to put 200 here and 200 here. So what will happen? So this was 1000 milliseconds, which means it is 1 second, but now it is 0.2 seconds. So the speed, the frequency of the light should go up. That is what it should happen. Normally the frequency should go up, and we are loading it. Yes, you can see that the frequency has gone up, right? So you can use this simulator to fiddle around, to work and understand about Arduino Uno, to carry out the practicals. Even if you don't have physical devices themselves, if you are interested, you can check a video on YouTube of a IoT project, and you can create the entire project here as a simulation, right? So once more, let's make it a little bit. We will increase the value for, let's say, 3000. That means we have to wait for 3 seconds. Yes, we have changed the frequencies. Now you can see that it will stay on and it will go off in 3 seconds. By changing this value, of course, these things would change again and again. 3 seconds it will be off for small time and it will switch on again. Okay, so now we have a basic understanding of how this is done. Which part is going to be connected to the PC? It's going to be here, this one. This cable will be connected to the PC, but of course this is a simulation, so it will not be there. Additionally, you will so these are the basics, right? We are still talking about basics, right? There are many sensors that are there, including different kinds of screens, slide switches. We have different kind of circuitry we need. We have keypads. We have sensors. We have the ultrasonic sensor. We have these sensors. Now I think you will be able to recognize this is temperature, and this, of course, this is a temperature and humidity sensor, right? This is a separate temperature. Remember, we talked about different models. We got these examples, right? Motion sensors, right? We have different kinds of sensors that we need as well. We have servo motors, different kinds of relays. We have breadboards, so on and so forth. Let's take a breadboard for a moment. Okay, now because we are taking a breadboard, why are we taking a breadboard? I just wanted to show you how the connections are going to be made, right? So that we can move quickly. Yes, what we first said was, right, if we have a breadboard, these lines, this line, these lines are all connected together. These lines are all connected together, right? So if we have this one over here, let's say we will go to the last corner over here, right? That means this line and this line is sharing the same thing. How? Let me show you. Now if I have a connection to here and we will connect it to second line, right? As you can see, if I just, okay, right, let me move it over here into the middle, and I will move the line to this position. Right, I will take the line from here to here. Line, this is the cable connection, right? Then I would take this one over here and I will ground this one, yeah, right? So you can see that these are not directly connected, but because these are in parallel connections like this, the circuit technically the circuit should work. So let me put this to 1000 again, right, when we will run the general circuit. See, it's working, right? But if you delete this, if you click something else and connect to 2, and if you run this, it will not run. It is, you can see it's running, the code is running inside, the power is going through the circuit to the second and up to here, and all these lines would have power right now, but from that point onwards it doesn't go anywhere. So there's no connectivity for that, right? It's just to show how this, so you can just fiddle, you guys can just fiddle around and understand what is what, right? Now this, okay, so here in the bottom right, if this is being selected, this whole set will get the same value, right? That is the difference there. So now from this, let's go to our traffic lights, right? What I have done is I have created, because time is our concern, I have got a mini breadboard from here, a couple of lights, three lights, 3 resistors, right, connected to red one to 2, yellow one to 3, green to 4, right? Connected them, connections are being created over here, right? You can see, and the rest of it are going to ground. So what I have done is, what we did in the single bulb, I have copied it for 3 bulbs, right? Okay, now we have the code here. We have defined our codes, right? We have defined, we have 3 names, we have defined our code, right? In this code, what will happen if I run? Red LED would go high, right? It's out, we have said, okay, red LED is output. Red LED would go high, we'll have electricity for 1 second, then delay it for 1 second, so it will be on high for 1 second, right? The process will, like, step by step, it will read, it will understand its output, come to the loop, okay, going into the loop, it will be high, okay, delay it for 1 second, stay for a second, then it will go for the next one, okay, red LED will go low, then it will wait for a second, then go up for the loop, and so on and so forth. So if you play this, now you can see, okay, it's on, this is running, and every second the red LED bulb is switching on, switching off, switching on, switching off. So we need all these 3 to function. How to do that? How would that happen, right? So because we have the code, we will just quickly do the necessary changes, right? First we have to define these 3 outputs, because we are giving separate outputs here, right? We have given green, yellow, all these. Okay, now what are the changes we need here? What are the changes we need to do here? When red is on, right, others have to be off. So in general, all will be off. So the first, so if you run this code, the first code will be running is high, so that means everything will be 0 first. So that means there will be no electricity flowing through these things. The first electricity flow will be happening for the red one, right? then it will stay there for 1 second. I'm just going to make it 2 seconds, right? Of course, if you're in a traffic light, you know that it will take 45 seconds or 1 minute or something like that, but just for our need, we are just going to change it for 2 seconds. What will be the next light, which will be what will be the next action happening? The red will be switching off. Yes, that's true. The red will be switched off. The yellow will switch on. Will there be a gap between those two? No, in a traffic light, there's no gap between those two. So that means it will happen instantly. Sorry, my bad. It will happen instantly, and when red is off, yellow will turn on, and yellow will be turning on for a very short amount of time, right? So there will be the delay. Now we know that red is off, only yellow LED is high, means it's switched on, right? Green by default is still off, right? Then we go to the next step. Then what should happen? First the yellow should turn off. Yes, this should yellow one should turn off. Then what should turn on? Yes, then the green should turn on. Right? Coding is simple, just need to keep to keep a small understanding, or you have to have the picture in your mind what is happening. So in that case it will be easy and you will understand it genuinely, right? Basically, right, even if you don't know the code, but if you know, okay, this code will do such a thing, that means you just need to copy paste the thing again and again. If that doesn't work, you have GitHub, you have Google, you have Arduino page to support. You would you have you will have books, you will have everything you need. You will have other websites with codes, with projects, right? You can copy codes from that and edit in a way that you need, things like that. On top of everything, today you have AI, right? So chat GPT, things like that actually can push out codes as well. So then you will have the ability to chat GPT can quickly search the official code, copy paste without error, it will work. You just need to do the changes that you need it for your particular function, right? Then where did we stop? We stopped at, okay, yellow will be turned off, green will turn on, and green will also turn on, would have a delay. Then what will happen? Here's the tricky part. If we write the code over here, because always remember it will start from 1 2 3 4, it will go like this, and here it when it comes to the loop, it will start from here, and it will go down and it will go up, it will go down, it will go up. So the very first one, we cannot have the very green is, because we can have it, but it wouldn't make any sense. So we would just, now here we will switch off the LED, green LED, right? It will turn off, it will go low, then quickly it will go up and the red will get high for 2 seconds. Okay, so this is the general code for lights being changed up and down. Have we built a traffic light? Let's see. Red, yellow, green. Red, yellow, green. So yes, in yellow it stays for a small time. Oh yes, I forgot about something. It doesn't happen like this, isn't it? This part should repeat itself. I don't know how I got my driving license then. This part should repeat itself, right? And uh, yellow should go low and red should be coming up. Yes. So it should be red, yellow, green, green, yellow, red. Yes, it should be like that. So this is like a basic traffic light working, right? You can change the times by changing, you can by delaying the change in the delay time, right? This is a simple workshop of how that is being done. Of course, you can fiddle around, you can understand what is what, right? You can see what are the errors, or trial by error you can learn and you can understand. I will share these links, right, as well for your training purposes. Right, so in my mind, engineering is something that is not constrained to your degree. You can just have a degree and then you can just forget about it. Or if you are actively pursuing, if you a career on this, if you are going to start a startup on this, then you should learn more and continue, and these things are very good for you in learning and understanding. Okay, now you can see how a traffic light is working, right? The circuit would look like in the one in the picture itself. You can see how a LED or a traffic light works from Arduino, right? If we are to build this on mass scale, right, there will be a lot of LED bulbs. That means there will be a lot of electricity being used. So the power sources must come separately. It should have relays to handle the power which is coming in, so on and so forth. But now you have a general idea of what a LED project would look like, or how to handle LED lights. So we are taking small steps, baby steps. Now we have gone through Arduino, from LED to, we have understood what is a breadboard. We have understood the connectivity between Arduino and the breadboard. We have understood how you can connect or assign a pin to Arduino itself, right? And we understood why we use resistors and things like that. So there are some basic things like that you have to learn by yourself, as well as we talked about when buying a sensor, you have to check the uh, documentation as well. So the next step would be to uh, from a actuator, let's go to a sensor. So this is a example we talked about time and time again, a practical example, our temperature and humidity sensor. And in this case we will be looking at temperature itself. So we have the voltage, we have the data, we have the ground. These are the three main points. Um, Here we will be using the sensor DHT11. There is another sensor DHT22, which is also similar to this. The version would be quite similar, right? Very simple connection we have to carry out. This is an example diagram of the connection itself. We have the ground. Here also you can see that there's only 3 pins in the 3-pin connection method. So the fourth pin will be, here we have 4 pins, but this one is not applicable. So we have the ground directly. Ground will be connected to the ground. Then the VCC would be the power source. Uh, we can go through the data sheet and we can see what is the power needed, right? We can directly give power from a 5-volt output. Where is the 5-volt output? We talked about it when talking about Arduino circuits, right? There is a separate 5-volt output on Arduino, so you can use that to give the power input for this. So that means, okay, 5 volts is given out. Will that be, do we need to connect a different power source to the Arduino circuit, or can we use the USB port to power this circuit? What do you think? Because this is using only 5 volts and we are not going to connect any other sensors or devices on top of this which consumes more power, it could work from USB port. The power from USB port is more than enough. If we are to disconnect the USB port and just use this as a single device, we would need to supply electricity as well. That is a point that is needed to be to keep in mind. On top of it, the power can be given through a portable USB charger as well for the USB-B port. Okay, so the data pin. So data pin here is connected to pin number 2 according to this diagram. So the data pin will be the one that we will be considering a lot. So components together: Arduino Uno board, check. DHT11 temperature and humidity sensor, yes, we have that. Breadboard and jumper wires, yes. So again, breadboard and jumper wires. Now I think you are familiar with breadboard, jumper wires. Step number 2: connect the components, connect the sensor to the Arduino as follows. Yes, we looked at the diagram, right? Here we connected to pin 2 in this example, right? The VCC pin of the DHT11 to the 5-volt pin of the Arduino, so there will be constant electricity flowing through this. Power will be there. Connect the ground of the sensor to the ground and connect the out pin of the DHT11 to a digital pin on the Arduino. So here, if you buy this sensor and if you don't have this sensor or any other type of sensor, you should check the data sheet from the manufacturer itself. It is very important. Why it is important? So we will have an understanding of each pin, right? If you see here, this one, the sensor itself is connected to another board. From the sensor there are 1 2 3 4 pins coming out, right? And they have only 3 pins going out. Here we can see from this diagram the data is given as the middle pin, not the middle one, the, let's say, from the left, the third one is not applicable. So in the other side of the circuit board, it would generally be marked as VCC data or output. So you can see out is written here, and the ground. So these, you have to look at the diagrams right? It is better to when you are just starting your IoT career, when you are just starting to do your project, it is better to have standardized equipment, devices, sensors, and actuators, which are maybe on the Arduino site itself, because life will be easier. We talked about this before as well, right? And this would be clearly marked on the sensors or the boards as well. When this connection is done, when this particular part is done, we can write the code. First, include dht.h, which means we are calling in the library for this particular sensor. Define DHT pin for two. So we are defining that pin for this one, or here you can use the integer uh, type. I think this is more valid using this one, right, to name the pin we want. This constant int name equals to the pin, right? uh, right, so we know that we have made the connection on pin number 2. Define DHT DHT type as the sensor type. So we are taking DHT. As I told you, there will be plenty of sensors. I told you there's another one, DHT22. This is DHT11. So there will be a set of sensors. So we are just defining that this pin is connected to this. One point to remember: where we are getting these things, or these points like read temperature, right? Are we getting these things from somewhere else? uh, where does this information come from? So on and so forth. They come from the datasheet, they come from GitHub accounts of these sensors. So those things are, that's why we call this library DHT library. We call this library because of that, right? So the best thing to do when you are starting it up is to look at examples and use already written code, or already in use sensors. Don't look for very complicated or very new sensors, because the older the sensor is, there will be people who has done projects with it, there will be enough code to understand it, right? Or otherwise you have to be a pro to understand the electronic part of the sensors and the actuators, as well as the coding part of it, right? So it's better to have, like, if you have this code, again, use Google, use GitHub, use ChatGPT, or use any other website which has done projects already. Use books written for these things. Use already pre-existing code in the internet. When you type in, okay, this is the sensor I need, you will find these pictures, you will find these data, you will find this code even, because this is a standard code. For example, right, this is the basic example. What we are going to do, we are just going to read the temperature, that's it. This data will be there. So if you are going to add on top of this, you can modify it any way you want, but for the starting part of it, this is important. So then what we do is we go DHT, we define DHT, right? After that, void setup serial bin 960 serial begin 9600 DHT begin. we are just making the connection with the we are making the connection with the sensor, right? The because these points are already there from the library itself. We are calling these points, right, to for the serial beginning and everything. We already have that code written in the library. We are just calling from the library itself. Then void loop, yes, we are starting a loop because we are going to censor it again and again and again, because temperature differ from time to time. So if you are to develop, let's say, a thermostat, we talked about smart thermostat in IoT devices. So if you are to design a thermostat, you should always keep making readings. Float temperature equals DHT read temperature. So this, what does this do is it reads the temperature. Serial print, we know that temperature, this is just a print, right? Serial dot print is, it's going to just print temperature. Then serial print temperature is equal to DHT read temperature. This would read temperature from the DHT sensor itself, and again serial print dot Celsius, it will read in Celsius. Delay it for 2 seconds, repeat the whole thing again. What will happen is temperature will keep on printing this and this, so on and so forth. Here we have the steps. Let's go through the steps. Install DHT library, open Arduino IDE, go to sketch, yes, we know, include libraries, manage libraries, so on and so forth. In the library manager, search for DHT and install DHT sensor library by Adafruit. Yes, now we know where's the company. This DHT is made, DHT11 is made by Adafruit. Step 2, write the code. Write the code. Here's a simple Arduino code. So we have the Arduino code of the for the sensor. Upload the code, connect your Arduino to your computer by USB, select the correct port, then just run it. So the temperature, where would the temperature be shown? The temperature will be shown on your PC, because you are running IDE. It should be displayed on the PC itself. Who makes the library? Adafruit makes the library. How does this thing becomes easy? The library is already there built in on your Arduino IDE. You need to go to sketch, include library, manage libraries. Then in the library manager you have to search for DHT and just install it, right? So you will get the temp. So this is a simple example of how the temperature sensor works. That's it. If you run this code, the temperature will be written anyhow. Rest of it, what we can do is, we know that okay, this temperature value, right, this temperature value is equal to this the reading, right? So we can use this temperature value. If this sensor is connected to your AC remote or something like that, then we can add more instructions here and continue like that. Here's a simple diagram, image of how does this look like when it is connected in the physical format, right? I wanted to show that as well. Then on top of it, this is something that is being extended a little bit more from the physical format to having a screen. Now, when you remove this cable, right? When you remove this cable, now this you can take it as a thermostat. This is a genuinely a thermostat. How? When you remove this cable and you plug in a power source without the laptop, you can say a USB power source or something, you have the embedded system which will process, which would have the code. You have all these connectivities, you have the sensor, you have the screen. You just need to build a nice beautiful cover where you can only see the screen only, the internal parts will not be seen, right? There should be a small let's say a gap or a pocket for this sensor to get uh, the temperature from outside. That's it. So this is a prototype. When building the full machine, these wires will be not there, everything will be connected together. A very smaller board will be used, so that the device would be a very small device which will show the temperature. So this is a IoT device. Depending on this temperature, we can take other uh, steps, right? So similar to this sensor, every other sensor works in a similar fashion, right? It is your job to find the particular set of data. It is your job to understand what is the code, which part is being drawn from the library itself, right? And how the code is run. So we are back again here in the simulator, right? And I found this code as a project, and I decided that it would be a good example for you. This one, it is DHT product, but it's a DHT22. It is very similar, almost same as DHT 11 that we were talking about, and as you can see the code get in the library in, right? We have the library in, and then we have the same code similarly, right? For we just need to change the DHT to here and carry out the same code. Serial begin is a little bit different from DHT11, but as we have the information here, we can run it out, right? So here DHT begins. So it will be connected through the serial, and of course we take temperature here. We know that this sensor could take humidity as well, so I'm not going to delete these extra lines, right? I think by now you saw, okay, we take temperature by this, read temperature. Similarly, it's read humidity. Where this read temperature and read humidity comes from, it is directly taken from the library. You can see that DHT library is called, so from that library DHT dot read temperature is taken out, right? Here they have also added an extra if function in the middle, just to see if the humidity and temperature is giving out any errors, right? This is some so it's a error reading. So these extra parts, error readings and things like that, is very important when developing a final product. When developing a final product, these small things like that are very important. We have discussed these parts on applied IoT, but here in IoT, our main focus is to take our first steps right now, to build IoT devices. Similarly, in that code, we can see that uh, we have humidity and temperature to be printed, right? As well as there will be a 2-second delay where the loop will start again. First, it will check for any errors. Um, it will check for any errors. If there's no errors, it will print. To wait for 2 seconds, go again and again. So what will happen is, according to this code, when I start the simulation, technically it should give out readings for humidity. So it should print humidity, then the humidity value, then it should be uh, printing temperature and temperature value, temperature in Celsius. Let's see if we can get this outcome. So yes, we are seeing that the code is code is now running, right? And we can see the temperature has been read, and the temperature here is marked as 24, and humidity is 40%. Of course, here the thing that you have to always remember is that this is a simulation. If you have the uh, physical device, you can keep the device near hot water, and maybe near steam, and check whether the humidity goes up and the temperature goes up, or near a candle you can check, near the candle flame you can check whether the temperature goes up, and see if the readings are changing, to see if the readings are correct. As this is a simulation, it will be like this, right? So this is a simple way of looking at it. We are now here in the simulation, we are using DHT 22 simulator. So we talked about the library. When we typed in library, you can see in Arduino and GitHub, the library is pretty much there. So we have different versions of it. Technically, this library should be also there in the IED, so you can pull it from the IED itself. You don't need to take it from here, right? We have the documentation. Yes, documentation directly goes to the GitHub page, and in GitHub you will find all the information which is needed, including the code examples and so on and so forth, right? So you can dive into these things, and you can figure out what is the code, what is what. You can see which code we are calling in. Over here we can see, but these things we don't like right now. These are not things that we are going to fiddle with, right? A day when you have done your masters or PhDs, or for designing your own sensor, yes, these things should be learned. But right now our concentration is on making a sensor work, right? So if we have a sensor like this, right, then what else you can think? Okay, we have a sensor, we would add right, we can add a LED to display this information on it. We can add so we see we have a IR remote right here as a simulator. So if you go through the code, or if you have if you have time, right, you can use the IR remote, and then you can program the IR remote to give out a signal. What would it do? If the IR remote is pointed to the AC itself, you can build a thermostat which depending on the readings which given here, and you can say okay, we right, if we can put a if function, and we can say if temperature reading here, it would be, yeah, it would be temperature is greater than, let's say, greater than some kind of a value, right? Let's say it's greater than 30, then the IR remote will switch on the AC, things like that, right? We can make it more complicated, we can make it more have switches to this, so on and so forth. So yes, it is something to be fiddling around. So these are the basics of what we are learning today, right? Now I think you have an understanding of how to. So here we have another, if you have the not the library but the documentation and the information, here you will find, when you type in the sensor name itself, right, we will find the data sheet, we will find, right, in the data sheet you will find all the information. Different companies have their data sheets. Let's see, what is this? We have a PDF, I just opened it. Okay, Adafruit one. Let's okay, we have both of the sensors here. We have 11 and 22 here. We have the sizes, we have the connectivity, we have the code, so we can see how it is been, it would print similar way, right? We would get all the information, import code, Adafruit, so on and so forth. Okay, we have a Python script, right? And so on and so forth. So these are like intricate details are much unnecessary, because I just wanted to show here is that things that we have to check is main functions, for example temperatures, right, accuracy, measuring range, right? Now you can't put this on like near boiling water and take a correct, because boiling water is 100 degrees, you can't take a good reading out of it. And here operating voltage 5.5 is okay, so that means we don't need a resistor, things like that, small things, but we need to check them before, or otherwise we would be just buying a sensor and burning it, which is not a clever idea. These all, you can see how the readings are taken and how the calculations go through, but those are complicated, like beyond what a IoT engineer scope, it goes to a electronic engineer scope, right? So that particular points are not much needed, because those are not the points that we are concentrating on. Let's say this, we would say sensor Arduino code. We'll just write something like this, right? We will get some examples. Okay, we have a project here. We have diagrams drawn in, right? And we have Arduino Uno, the sensor, breadboard, jumper wires. Yes, we have. They have the ordering options as well. So then the story, we have gone through the story, we know the story. We can see that, okay, 4 pins are there, 3 is not applicable. You can see that the connections are being taken place, jumper wires are being connected, how it's working and how the data is showing, right? And okay, you have a video for the same, and we will go down. right here, schematics and the code. Here we have the code, right? You can, when you are doing a project, you can rely on a code like this. Okay, this is a very simple code, simply written, right? And you can start modifying it the way you want, because we are sure that this is already working. There are chatbots to talk about these things and so on and so forth. I just wanted to show you this example because to show you that these codes and everything are available, right? So if you are to build a IoT device, you don't need to stress out much by, you know, from the beginning building a code. Yes, one day you will, but before that, because we are on the starting stage of these things, right, you don't need to use much of your uh, efforts when you are building the initial prototype or doing the initial project. uh, so now we talked about we talked about LEDs, we talked about uh, a very simple LED and a very simple LED lineup, which with three lights. Now we came into a sensor where humidity and temperature is being measured. I think now you have a basic example of what to connect, how to connect, and how to carry out each of these functions. Uh, so I think now from here you have a basic understanding of what to do with Arduino, right? If you get the steps would be the similar for if you take Raspberry Pi as uh, embedded system to be used, right? Mm, you just need to follow the steps that you followed in Arduino. What we did first, we set up Arduino, we learned what is the IDE, we learned how to type a small code and update a small code. So what should you do in Raspberry Pi? First thing, how to set up Raspberry Pi. You can just go to uh, you know, Google, type it in, or YouTube, it would be the best, right? You will get visual demonstrations of how that would be done, and then you will learn how to use that interface, because Raspberry Pi is completely different from Arduino. Arduino does not have that much capacity as Raspberry Pi. Raspberry Pi is uh, a small pocket-sized computer in itself. So the interaction between the two devices a bit is different, but the end result would be the same. So after that, then you will know, okay, then how to light up a LED bulb from Raspberry Pi. Then step by step you can move forward. Same with Arduino. Now you know that, okay, temperature sensor is like this, but we learned about a lot of other sensors as well, right? I'm pretty sure that we did learn about lot of sensors and lot of actuators. So there are input devices, including, okay, we have sensors. We learned about ultrasonic sensors, right? Why ultrasonic sensors are mainly used for for motion sensors, so sensing anything is in front of you to sense the distance, so on and so forth, right? We have a separate motion sensor as well, right? This is the sensor that is normally used for lights that are being turned on automatically when somebody moves near it, right? We learned about these things, so we can by understanding the requirement, right, understanding the problem that we have to solve, by understanding the requirement, you can use the sensors accordingly. That is the most important part. So now I think by now you have a basic understanding of uh, Arduino and Arduino prototyping or project creating. Of course, when you are creating or prototyping with Arduino, it is not the final product. We talked about IoT devices with multiple sensors and multiple actuators. So when you see the final product, it's not the prototype like this, right? It would be a embedded, maybe a separate circuit would be there, wiring would be different, sensors would be maybe custom made, things like that. But each and every product started their life from a prototyping phase, which would start with, could be Arduino, and so on and so forth, right? So that is the main point. Now I think you have a general idea. We started uh, now I think you have a general idea on how to deconstruct a IoT device, right? Deconstruct a IoT device and understand what are the actuators, what are the sensors that would be there inside it, because you know the functions of it, right? So what a IoT engineer should do is look at a problem and okay, we can solve that problem using this solution, and we have to construct such a IoT device. When constructing IoT device, let's say temperature control. So temperature is the problem. We have to have a temperature management system. So if you have to have a temperature management system, what would be the first thing you need? We need to know what is the temperature. So you will be starting by using a temperature sensor and measuring the temperature, right? After that, what would it be? We need to control our ACs according to the temperature. Within this Arduino device will be connected with a IR remote, which can communicate with the AC, right? Just a small example. So the AC can be changed. Things like that. We talked about, look, even the LED thing, it's a traffic light. If we have image processing and so on and so forth, with more processing power, end of the day, you will have a total IoT system out of it. But end of that IoT system, there will be a traffic light simply working the way we designed right now. The values will be changing automatically, so the code will be complicated, but the principles are the same. So I think we have covered around 2 hours for this lecture, and I think now you have a good understanding of the very basics or the fundamentals of Arduino programming or prototyping or making Arduino project. So we will stop from here now, because on top of this I will share the information on the web pages we use, the simulation page, web page, and a couple of other documentation on top of it, the videos that are there, so that you can go through them and have a idea of how to start with Arduino. Okay everyone, thank you very much. Have a great day.